It did happen. We had a test number 4 of the Starship. And this one is really the one that pretty much says they can do it. I mean, it's unquestionable at this point. For those who don't follow these launches that closely, even just terminology, Starship refers to the whole thing, or it can just refer to the top, the second stage. During some of the announcements, they just called it SHIP, the SpaceX people. On the bottom, you have the booster, or the super heavy booster, or the super heavy. You hear all those variations as well. In between is the hot stage ring, which was relatively new. And that's so that as they launch, they can start firing the engines on the top stage before they separate from the booster. But as a result, there's a lot of thrust, high temperature, pressure, everything. That would damage, obviously, the booster pretty badly. So they have to have a separate ring which deflects that thrust and temperature and so on. So we refer to the hot stage ring, and you'll hear references to that at times. If you look at that picture, you might be wondering, well, why did they paint it white here and there? Well, no, that's not paint, that's frost. You think about it, they're loading it up with methane and liquid oxygen. The methane at atmospheric pressure is like minus 260 degrees, so it's cold. This is the Gulf Coast of Texas. It's pretty humid. So as a result, you get that frost. In effect, you can measure the liquid level, how much fuel they put in. Over on the left-hand side is the actual display from SpaceX there. And as you can see, they were about halfway filled on these tanks, and you can see it pretty directly. You don't see that on the upper stage because you have those thermal tiles there, at least on this side of it. So you can think of that as being kind of like a Yeti cooler or a half of a Yeti cooler, because the other side is actually still stainless steel exposed. They only put the tiles on what's going to be the bottom as they descend, because that's where they're hoping to get most of the energy being absorbed. It was a lot similar to Flight Test 3, except that everything worked this time. They did solve a lot of the problems along the way. The big thing, the goal they had was they wanted to have controlled landings all the way down. And the biggest problem they had, they lost control. Actually, both for the booster and for the upper stage in Flight Test 3. And they addressed all that. Biggest problem was they apparently had clogged lines for the attitude control thrusters. The smaller thrusters that actually are used to point, to make sure you're pointing in the right direction. And they also just added more of them. If this is going to be a problem, they better just make up for it with brute force, just like having more engines. Same kind of thing. Have more thrusters. They're small, but they're important. The key thing here is that both of the stages actually landed vertically as they wanted to. They wanted to have landings in the ocean, and that's what they did. The picture's at the bottom here. The left-hand picture, what you're looking at there is when the first and second stages separated. The one in the middle is when the booster had almost landed in the ocean. I mean, it's kind of tipped just from the angle of the camera, but you can sort of see the water there. And on the right, that's just an animation. That's not an actual picture. The idea is they were going to try to land vertically at a predetermined position in the ocean to show that they could do it. And then at some point, obviously, it's just going to fall over and sink into the ocean. But the main thing was landing vertically on the water, which they essentially did. So that was quite an accomplishment, really.
The question arose, would either stage float on the water?
Their plan was, if they needed to, they would purposely trigger some explosions just to make sure it sank. Whether they did that or not, I don't actually know. But there's some valves left open. I mean, eventually water would kind of get in there, but you think it would take a while. That was a question everybody had back then, but the intention was it would just sink. Okay, I actually have a video of this. This is the booster. This is an actual picture of a landing. They apparently had a buoy right at the spot where it was landing. That proves that they managed to land it where they wanted to. That's what it looked like. And then this is the view from the ship itself as it's going down. I guess they didn't show it toppling over.
I hear Elon is highly considering trying to catch the chopstick.
Yeah, he certainly got enthusiastic, I think, because of seeing this. He just said, yeah, let's actually try to bring it back. I mean, that's, of course, the goal is they want to bring back, eventually, both stages return to the launch site. And that would be the next step, obviously. Now, this was the hot stage ring being dropped off. They said that they had to add the hot stage ring in between the two stages as a result of earlier testing. And that thing weighs 10 tons. I mean, if you're going to stop the thrust of those huge rocket engines, it weighs a lot. And apparently that threw off all their calculations all along. So this time they said, well, okay, let's just drop it off. It's a temporary thing. What will actually happen in the long run is that, one, that they won't have a separate hot stage ring. It'll just be built into the booster. And they'll also make the booster a little bit bigger, just to make sure that it has more fuel and it has more thrust. They did some sub-tests along the way. You're looking at the upper stage here, and those hexagonal things, those are the heat tiles. But you'll notice there's a couple of holes. They purposely left out a couple of tiles in areas they didn't think were too sensitive because they wanted to get some data on, well, what happens if you're missing tiles? How hot will it get? So they have temperature sensors in there. I have not heard anything about the results of that, but obviously the mission succeeded, so apparently it was okay.
There's also another tile in there, and
there's a thin one somewhere.
Yeah, a thinner one just to the right. You're able to see it in some of the photographs, distinctly thinner.
Yeah, but it's interesting. I mean, everybody was worried with the space shuttle. My God, if a tile flies off, well, that's the end of the mission. And here, well, let's experiment a little bit. Let's just take a couple of them off. But they're not as worried. With stainless steel, it handles the high temperature much better. It also handles the low temperature much better, the cryogenic fuel, the cold fuel. So it's really better all around. They know they can miss some tiles, and it probably isn't the end of the world, but they want to get some real data. And they kept saying the payload here is data. What they want to do is learn as much as they can, and that includes purposely taking a chunk out of your thermal protection system. Yeah.
So, Greg, when I was at NASA and I talked to
David Chevron commented that when he was at NASA and SpaceX was competing for early Falcon contracts, they would do things like throw nuts and bolts into rocket engines running on test stands, and NASA would never have done that sort of thing.
This is what testing is all about. Yeah, there's such a huge difference in philosophy and how SpaceX runs things. They're willing to do those kind of tests. They call that a hardware-rich environment. It isn't like some of the others where they try to simulate everything and then just, get it right the first time. That's pretty hard to do because there's things you don't anticipate. Yeah, like what happens if a pebble gets in there? Well, and the results speak for themselves. I mean, they're easily 10, if not 15 years ahead of everybody else. Okay, so why did this tile thing matter? Well, you're coming down, you're going over 17,000 miles an hour. You got a lot of energy to dissipate, basically, to get down, and that's how they dissipate it. So they purposely fly at kind of an angle so that as they come down, the energy is spread over the whole thing. This is just an animation, but it looks like plasma. It gets so hot that everything dissociates into ions, and it's a whole messy environment. So that interferes with communications. They proved this during the last test. When you have this kind of a condition going on, you lose radio communication. And so what they did was they put on Starlink terminals, communications on the upper part of the craft. This is what it looks like on the top side. That can still communicate with the satellites because there's not that much of the ionization around it. And that's been working. So they actually were able to get all these pictures with all this plasma surrounding ships that no one has ever seen before. They just couldn't get it. And even just qualitatively, just looking at it, seeing how the plasma kind of streams around everything, you get a good feel. And you'll see some later where it was pretty disastrous. Yeah, like that. Okay, so what you're looking at there is one of the top fins. There's fins on the top and on the bottom that they use so that they can make a controlled descent. You don't need that on a normal rocket because you normally don't care what happens. You just let it fall. So they have to worry about it. So they have fins. And that's one of the upper fins you're looking at right there. And this is after it's been eaten away by the plasma for a while. It's falling apart. In fact, you can see there's one of the tiles that actually blew off, those hexagonal tiles, right there kind of in the center of the picture. Basically just gets eaten away. And everybody was kind of wondering, my gosh, what's going on? But even during all this period, you could see the fins were still moving. And they were still controlling. And they never actually lost control, which is pretty impressive. So there were a couple of failures, but they were not substantial. There were two engines that actually failed in the booster. One right away, right after takeoff. One of the outer ones. Those are only used during the initial launch phase. But then when they return, as they start to do the boost back burn, and in particular as they're starting to land, they need the other engines. One of them failed too. But it turns out having so many engines, you can afford to lose a couple here and there. And it still works out. And that's what they did. But anyways, back to this fault though. That flap was pretty melted. It got a lot of attention. They had already anticipated this might be a problem. And actually they have already done some better seals around the hinges. And I think they may have done some moving around. But one way or another, they had kind of thought this might be a problem, and they already had made design changes, which will show up, maybe not even in the next test, but probably in the ones after that. And of course, as we're saying, we're seeing this because of Starlink, the satellite communications. You never would have seen that kind of thing before. Now, you think it was bad here. Here we were at 54 kilometers up, still going 14,000 miles an hour. This was a little closer. This is when you're only 6 kilometers. It's hard to recognize what it is at first, that picture, but that is the same fin, same camera is taking a picture of that. It's just that a couple things happened. Well, one, it got eaten away a lot more. The other thing is the camera itself, the lens had cracked, and also it had gotten hit with a lot of debris, so there's all these extra black smudges all over everything, and that's just because the camera took quite a beating. Anyway, that's what the thing looked like. It still has 6 kilometers to go, but they were already down to 484 kilometers per hour. You're already subsonic at that point. And visibly, it was still controlling, and that's really the important thing. Because if they lost control, they never would have done the controlled landing at all. They actually managed to relight the engines on the Starship and do this vertical flip and land vertically. It wasn't clear if they really landed at 0 miles an hour. You couldn't quite tell that. They'll probably have more to announce about that. But fundamentally, it came pretty darn close. Now, so future flight tests, what has to come along in the future? One big one that they actually didn't do during the third test either is starting an engines while you're in orbit on Starship. They haven't done that yet. It was just a ballistic trajectory. They shot up getting to orbital height in such an orbit that it was going to then take them back toward Earth. And that way, in the event they couldn't relight the engines, they weren't stuck with an out-of-control rocket. It had a ballistic trajectory. So they need to do that. Then they can start testing actually going to orbit. So this didn't achieve, and it wasn't designed to achieve a full orbit right now. And then what they really need to do is they need to show that you can transfer fuel between 2 starships. And that's a little further down the road, but you have to achieve orbit before you can do that. They need the fuel transfer because as part of the Artemis program to go to the moon, you got to load up. You basically have to turn one Starship into a fuel depot and have a bunch of ships come up multiple times and fill it up. And then finally returning to launch site. And as Nathan pointed out, they may actually be doing that, maybe the next time. Instead of just dropping in the ocean, they're talking about coming back to the launch site. You have these giant arms called the chopsticks that'll just kind of reach in and grab the thing as it drops. Maybe that payload door opening on the previous test, they didn't do anything with it this time. They sort of said that it worked, but it was not really very convincing. We talked about this at the time. You looked at it and you go, that just looks kind of shaky. Yeah. So, yeah, this was not really a main point of this test, so they just didn't worry about it. This is the Starship taking off. I'll point out something. This is like 1 second, T+1. You'll notice the clouds shooting out. They go out in all directions. Everybody criticized SpaceX early on when they didn't put in flame deflectors and stuff. And if you look at a typical launch site, including even some of the Falcon 9 ones, typically it just shoots out on one side. And their point was having this big milk stool kind of thing to have it sit on, it just shoots out in every direction. It means that the forces that are exerted and everything are actually less because they're spread around the full 360 degrees. They're proving that right there.
I can imagine with a ship that size, we had a flame trench, the launch pad might move over a few feet every time we launch.
Yeah, really.
Yeah, it's not an easy problem to solve. So it seems like they've got that down now. Okay.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.